Okay, we're getting thumbs up
All right.
for our call.
All right, here we go. So, yes, welcome to Plait.
Welcome. We welcome you.
Hello?
Hello.
Phil. We can't.
There's a thumbs
There
up.
you are.
Hey!
Hey. Hey. Welcome.
Hello.
Can't hear him.
Speakers muted.
I heard him for like a second.
Can't hear me.
Hey.
There we go. Now you can hear me because you're cheering.
Yay!
You should be cheering when you don't hear
but-
me, but okay, that's fine too.
Good morning. Happy to see
Howdy,
you.
everybody.
Hello.
Hello.
How
How-
are you doing?
How are you?
I'm okay. How are you?
We're doing good.
Yeah.
Yeah, not. I mean, a little tired, but it's still early days. You
A
know.
little tired. You just started.
Yeah, well, it comes and goes depending on who's in the room and various things. The level of tiredness goes up and down.
Right.
Or
Well,
insanity.
how much money have we raised so far?
We are. We're coming close to $94,000.
Nice. Okay, very nice. I like hearing that.
So yeah, thank you for maybe for those people watching at home. If you want to let them know who you are and why you're so awesome to have phoned in.
We've tried to explain.
I'm just this guy sitting in my room talking to a bunch of people somewhere in the internet land. Hey everybody, my name's Phil Plait. I am an astronomer and a science communicator. I write the Bad Astronomy blog. I've written a couple of books. I've shown up on TV shows on occasion talking about astronomy and space science. And I'm a friend of Liz Smith's, and she invited me to come on this and help raise a little bit of money for kids, for charity. I love this, and it's always a pleasure to be here every year.
Thank you so much for coming.
Do you regret now that now it's like Phil Plait, the Bad Astronomer, is on? Like, in hindsight, would you have gone with a different name?
Oh, I regret everything in life. But yeah, I should have gone with my first choice, which was actually Neil deGrasse Tyson. But later, that was taken. So I'm kind of stuck with what I've got.
Tragic.
So as always, we do have a number of questions for you.
Oh, great.
Given in by our chat, some of which are not silly, or not terrible.
I'm not sure I'm going to bet against that, but
All
okay.
right.
I've done this before.
First question here from Artemis Huntress says, I am doing an astronomy REU this summer. How do I decide what I want to research? Astronomy is such a vast topic.
Oh, that's easy. You go to YouTube, you type in Crash Course Astronomy, and there's a 46-part series with everything in astronomy in it, and you just watch it and decide which one you like. There's something about almost every topic, and I say that because I wrote it and hosted it. But it's it honestly, you could. You could, and I'm joking, but now that I say it out loud, it kind of makes sense. You could look down the playlist and see what topics sound interesting, and each episode's about 10 minutes, so you can get a taste for it. Or go to the library, I hear those still exist, and find an astronomy textbook or just a book and see what topics are in there. I mean, I spent a lot of time doing research in astronomy, and I didn't know the kind of objects I wanted to study, the kind of things I was interested in, literally until I was in graduate school. And I was in a class, a seminar class, and they had invited an astronomer from another university to come and talk. And he talked about dying stars, which blew off these winds of gas. And I was fascinated by these, and it turns out I had sort of a nice intuitive grasp of them. And I wound up studying them for many years. And then over time, just wound up finding a lot of other things that were interesting too. So keep an open mind. Just because you don't know what you like yet doesn't mean you won't find something that you will like. that sentence got away from you a little bit. I think you know what I'm trying to say. And just poke around and see what's out there, and I'm sure you'll find something that'll make you go, oh, hey, this is cool. And if you don't sweat it. The point of the REU is not to find what you love, it's to find something to do and to work with professional astronomers and get a taste for that environment. So even if you're not overjoyed with what you're doing, the situation itself is the reason you're doing it.
I like someone in the chat says, try to pick seminars where they serve donuts.
Grad school.
Coffee's more important, but okay.
Yeah.
Donuts are secondary.
It's a good question here about fostering love of outer space. Says my 4-year-old niece absolutely loves the solar system and planets. What are some fun things I can do with her to foster her love of outer space and science?
Well, you can go to YouTube and type in Crash Course Astronomy.
Noticing a theme here.
No, 4 years old. That's amazing. I didn't get hooked on astronomy until I was 5 or 6, so she's way ahead of me. A good thing to do, find a museum nearby. They typically have space exhibits. If there's a university nearby, they may have an astronomy department and an observatory. You can take her there and let her look through telescopes. There are generally astronomy societies, clubs, locally. I don't know where this person lives, but unless you're really far out in the middle of nowhere, chances are there's an astronomy club near you. And if you're out in the middle of nowhere, chances are there's an astronomy club near you because they like being out in the middle of nowhere where there are no lights. And they have star parties. They will have events where the public can come and look through the telescopes. She'll love that. Now, right now, sadly, I'd have to look on a star map, but I don't think there are a lot of planets up in the early evening. I think Saturn is already pretty low. But in a few months, they'll be back up, and the moon is always nice. So if they have a star party or something when the moon is up, looking at the moon through a telescope is kind of life-changing. It's amazing. So anything like that, anything you can do to get her at an eyepiece or to be thinking about astronomy. There are activities online you can find. There's let's see, she's 4. Star Child, I think, still exists. That's a NASA website for littler kids. And can't remember the name of the other one for older kids. And there's also NASA Space Place, which has lots of stuff online that you can show her. So that's hopefully that's enough to get a start.
Oh. Thanks. That sounds really cool. Yeah. I love the idea
Apparently have more of that information at my fingertips than I expected. That's actually kind of interesting. Okay.
I love the idea of star parties. I didn't know that was a thing, but it makes so much sense. I love it.
Oh my God, I've gone to a million of them, and I love it. I mean, it's so much fun. You can just look through. I mean, people bring their telescopes, all kinds of different telescopes. Everybody's super enthusiastic, and it's a lot of fun. Oh, and the Leonid meteor showers, actually, it's the 18th, probably over by now. But there are also meteor showers, and they do things with that, so a lot of stuff to do.
This is Tally asking. I don't know if it's our Tally, but yeah.
It's our Tally,
As an actual scientist, do you enjoy reading science fiction? And if so, are there any particular you would like to recommend, or any egregious ones that you would like to disrecommend?
Ha! Yeah, I see no way out of this question that doesn't get me in trouble. Just as a caveat, I don't do research science anymore. I did for a long time, but then I found out I enjoyed doing science communication better. I like writing and talking about it more than I like doing it. And so, once a scientist, always a scientist, I think. But I always like to clarify that because some people get all hot under the collar about, this person's not a real scientist. And it's like, well, yeah, if you got a PhD and you did research, I think that counts for a while. Do I like science fiction? Yes. I was raised on Star Trek and Lost in Space and Space 1999. And, oh my gosh, I started throwing out really obscure references. Quark? Does anybody remember Quark?
Yep.
I'm looking at you guys. You are nodding your head.
Nine.
You're a liar. You do not remember Quark. With Richard Benjamin? Really? Whoever's knitting. I'm sorry. I don't know who you are.
Emily.
my parents raised me on the science fiction they grew up with.
Oh, so you saw Quark, really? Oh my gosh. Yeah, it was a short-lived series with Richard Benjamin, and it was a satire about a space garbage collector. But, the point is, I watched everything. And I'm still a huge Star Trek fan. I like Star Wars, not as much as Star Trek. And, there's a ton of stuff on TV right now. The Expanse is really good. I don't know when that comes back on. And I'm enjoying Orville. It's hit or miss. Not all the episodes have been great, but the ones that have been really good have been really good. So there's a lot of good stuff on. I'm less picky about the science in science fiction than I used to be. I used to be a real jerk about it, like, oh, that's so fakey, and oh, asteroids don't do that, blah, blah, blah. I'm a lot more forgiving now. The story is more important. And in fact, I'm the science advisor for a CBS show called Salvation, which just got picked up for a second season about an asteroid bearing down on Earth. And it's more of a drama than science fiction. There's science fiction elements to it. I mean, the basis of the plot is about an asteroid. And, they've taken a lot of my advice for the science, and some of it didn't work for the plot, so it's out. And, I fight for it, and if they say, no, we can't do it to make the plot work, I'm like, all right, next. And we move on. So my advice is, I think John Scalzi calls it nerd gassing, where you're like, complaining about the inaccuracies of a science fiction show. Don't worry about it. Enjoy the story. It's okay. Let it go.
Choose your battles.
Yeah.
Yes, exactly.
As part of the same question, are there, that being, with the not getting too upset about things, but are there any particular tropes that really bug you that show up in sci-fi things? You're just like, come on.
Oh yeah, all the time. I'm not saying I take my own advice. I'm saying I'm a gigantic hypocrite. No, I mean, it's okay to be bugged by stuff. It's just at some point you gotta say, well, and it's all the standard ones. Sounds in space. The one that bugs me, I think, the most. It's not like I lie awake in my bed, shaking with rage, but the idea that in science fiction they ignore scale. Just getting from point A to point B, we have a faster than light drive. Well, okay, great. In Star Trek is really egregious about this, because it's like, how long is it going to take to get to the planet Rigel 8? Well, it's going to take exactly as long as to make the plot as dramatic as possible. There's no real, and every now and again they'll throw out something. I remember in the pilot for Enterprise, the captain and Trip Tucker, the engineer, they're talking about how fast they can get to Neptune and back. And it turns out, at warp 4.5 or something or whatever, the time they gave is right. The thing is, though, the time it takes to get to Alpha Centauri is still weeks, and that's the nearest star. So they mess with that kind of stuff a lot. And the only reason that bugs me is because I don't know how big of an impact this is, but I think people certainly don't have a realistic idea of the scale of the solar system and the nearest star. You go to these solar system scale models that you can walk around. They have a sun someplace, and you can walk to Mercury and all the planets. And it turns out, walking even to like Jupiter is exhausting. The solar system's huge, and it's really hard to display it on a scale where, if you have a realistic size for the sun, like it's a meter across, it's yay big. The Earth is going to be 100 meters away. If the sun is, that's about right. And that's a long way. That's 100 meters it takes you a minute or two to walk that. Maybe not that long, but something like that. But then as you go to the outer planets, it's like, Pluto is still 3 kilometers away, 1.5 miles away, or I think I've got that number right. But the point is, the solar system's huge, and the nearest star is tens of thousands of times farther away than that. So I wish people had a better grasp of the scale of the universe, and I don't think science fiction is doing us a lot of favors in that. But on the other hand, I don't know if people are really going, gosh, in Star Trek, they just went to the nearest star and it only took a minute. Why can't we do that? I don't know if that's really what people are thinking, but it would be nice if people understood that more.
It's like, I remember all the consternation with, was it the Alien, when they're like, we're hundreds of millions of miles away. It's like, well,
Yeah.
I guess.
Yeah, you can watch any old 50s science fiction movie and they talk about that. It's like, this spaceship came from 1,000,000 miles away, and it's like, yeah, that's 4 times the distance to the moon. That's nowhere. And Venus is 26 million miles away at its closest. So, 1,000,000 miles is nothing.
There are a couple of questions about these recently reported extra planets. We lost Pluto, but there appears to be extra ones out there that we may be having to put back in.
Right.
What's the deal with that?
Well, the deal is we don't know if they're out there. And the idea is that, first of all, because somebody's going to get all jerky about this, we don't have a definition for what a planet is. There's sort of an official definition which doesn't make any sense, and my advice to people is to ignore it. A planet is just sort of a big-ish object that's orbiting the sun. It's not something you can put a rigid definition on. So, if you think Pluto's a planet or not a planet, I feel that argument is kind of a waste of time. It's more interesting to think about, hey, what's out there? Let's take a look and see, and let the universe tell us how to categorize things. And what's going on right now is past Neptune, if you want to think of it that way, the major planets, there's a lot of real estate out there in the solar system, and there's a lot of stuff out there. And some of the stuff out there are these cometary bodies. These are giant chunks of rock and ice, and some of them are quite big as Pluto, 1,000 miles across or something on that order. And a lot of them are a lot smaller, 10, 20, 30 miles across, up to 100. And there are a lot of names for these. You can call them trans-Neptunian objects. That's a gigantic bucket name. Anything past Neptune is a trans-Neptunian object. And then there are subcategories. But the thing is, we've detected a lot of these out there, and you can trace their orbits. And you'd kind of expect that their orbits would just be in every which way. There'd be some going this way, and they'd be tilted in all which way and everything. And it turns out it's not the case. For a lot of these objects, when we look at them, especially ones that are out at a certain distance, their orbits all seem to be aligned. They could be elliptical this way or this way. They can be tilted this way or this way. And it turns out they're all kind of sort of aligned. And it's just object after object that we're finding is lined up this way. And it's like, that's suspicious. You don't expect to find them all nice and neatly ordered that way. And so some astronomers, including Mike Brown, who is sort of at the center of the whole killing Pluto. His Twitter handle is Pluto Killer. He thinks, along with Konstantin Batygin, who's another astronomer who works with him, that there's a 9th planet out there, or another planet, that could be as much as 10 times the mass of the Earth. Now, we don't have any planets like that in the solar system, and I'll get back to that in a second, that we've discovered so far. But if this thing is out there, by looking at the orbits of these other objects, you kind of figure out where it is. It's like if you're looking at a crowd of people and you see a disturbance winding its way through the crowd, they say, oh, there must be somebody walking through over there. Same kind of thing. All these objects are moving, their orbits are all aligned, and you can kind of predict where this extra planet should be. And so there are a lot of astronomers looking for it. I've looked at the data. I'm not an expert, but it's pretty convincing that there's something out there. Mike's absolutely convinced. He thinks it's there, and he thinks we'll find it very soon. Our telescopes are very big and very good, and our software is excellent at picking out these kind of things, so he may very well be right. And I love this because, well, it's another planet. That's awesome. But also, when we look at other stars, we're finding lots of planets orbiting them as well. This is something we didn't know about until the past 20 years. When I was a kid, we didn't know. Now we know of thousands of planets orbiting other stars. And what we're seeing is that, and I love this, these planets that are sort of in between Earth and Neptune, they're super Earths or mini Neptunes, whatever. These are the most common planets we are finding around stars like the Sun, and yet we don't have one. And that's super interesting. Why don't we have one? And these other systems don't seem to have planets like we do, or arranged the way we do. And so maybe we're kind of special this way, that all this is tied together. So if we do find that we have one of these planets and it's really far out, that's a huge clue as to how our solar system formed and what's happening in these other things. So yeah, this is super important. When they discover it, that'll be amazing. And Mike and Constantine will get a lot of credit for it. So, and what's funny is I think I just spent like half an hour talking about that.
No.
It's like that's just skimming the surface. There's a huge amount of stuff that you can talk about when it comes to this stuff. So I would suggest looking it up online. Look up Mike Brown. He's got a blog, and there are a lot of articles out there and everything you can learn all about this. It's really cool stuff.
I love this aspect of astronomy. It reminds me a little bit almost of like archaeology, where they'll or different things where they'll like have one little teeny like a fragment of a tooth, and it'll be like, okay, there was this whole thing here that we can infer from because of all the information we have and all these different things, that we can take this small amount of data we have and we can't see the thing exactly, but we know all this information and we can infer what's probably there, what will be there, all these different things. Very cool.
Yeah, I mean, Neptune was discovered this way. They discovered Uranus and it wasn't in the right spot at the right time, and they used the math of orbits and said, you know what, I think there's another big planet and it's there. And people went and looked there, and there was Neptune. So, this stuff works. It's kind of amazing. And that was 200 years ago. So we're a lot better at this now. So we're finding a lot more interesting things now than we did back then. So, we'll see what's next.
Oh.
Cool.
And that's it. You're out of questions. All right.
No.
Good job,
Just
everybody.
trying to get some... somebody's wondering, there's I don't know if you have any... experience looking at Destiny 2, the new Destiny came out.
What is Destiny 2?
It's a video game that just came out. But
okay.
But I think this is a question because it sort of takes place in space in our sort of supposedly in our or in our solar system, and so it's like saying that like this question saying like our universe, there's planets that are just a big empty rock with nothing on them, whereas in Destiny they're like super lush garden worlds and it's really nice. And it's saying like, is it cool to sort of imagine stuff like that, or do you think that's possibly detrimental to people's understanding of actually how the universe works? Or
Oh no, this is super important. I haven't played the game, so I don't know what the game is like. But as far as your question goes, science fiction has been doing this for 100 years, imagining what other planets are like, and in a lot of cases, it's wrong. They used to imagine Venus was a paradise or a swamp or very oily, a lot of different explanations for its thick atmosphere. Then we found out that no, it's actually it just has a tremendously thick atmosphere with a lot of carbon dioxide in it, a runaway greenhouse effect, and the surface is possibly the worst surface of any object in the solar system. It's hot enough to melt lead, and 90 times the Earth's atmospheric pressure. It's awful there. But using your imagination to try to figure this stuff out, that's what science is all about. Maybe it's not swamps on Venus. But why is Venus this way? And you have to use your imagination to figure that out. Why is Mars cold? Why does it have a very thin atmosphere? And it turns out, well, Mars doesn't have a very strong magnetic field, and so it's not protected from the solar wind. And so the solar wind, which is a stream of particles coming off the sun, basically sputtered away Mars's atmosphere over the past couple of billion years. That's bizarre. I mean, who would have thought that you could do that? I mean, planets change over time. And now that we're finding planets around other stars, they're not at all like our solar system. I mentioned this, but the first planets that we were finding are planets that are Jupiter-like, but they're orbiting their star super close. Like the Earth takes a year to go around the sun. Jupiter takes 12 years to go around the sun. These super Jupiters, or these hot Jupiters they're called, may take only a few days to go around their stars. So they are super close and broiling hot. And some of them are having their atmosphere stripped away. Other ones appear to be very dark. They don't reflect a lot of light. We don't know why. They have a high carbon content. Are they very rocky? What's going on there? We're finding planets orbiting binary stars. So you have two stars orbiting each other and a planet orbiting them, like Tatooine. Maybe you've heard of that planet. We found those are called circumbinary stars because it goes around the binaries. And there's I can't think of the name of it, but you can also have two widely separated stars going around each other and a planet going around one of those stars. We've seen a few of those as well. So what the universe is telling us is that it's very clever. And given enough circumstances, you're going to find planets in all kinds of bizarre orbits and circumstances that would seem like science fiction. When I was a kid reading science fiction, I used to think, oh, that's ridiculous. You couldn't have a planet doing this. And now we're finding planets doing that. So these games, the movies, TV shows, everything like that, where people make up weird stuff, I'm all for it. 99% of it's going to be wrong, but that 1%, that somebody said, what if we had a situation like this? If that turns out to be correct, that's fantastic. That just shows you that that imagination and science are intertwined and very important to each other. I mean,
Great.
There's a couple of questions about this. This recent thing of these two big, these two stars, merging or hitting each other, and the gravitational waves that they produced, creating a lot of new information that somebody says it solved astronomy, which seems a little overly zealous about it, but
yeah, we still have some questions. We're not done.
I have questions, but yeah, could you tell us a little bit about that?
No, I can only tell you a lot about it, unfortunately.
Well,
it's one of these things where it's like there's so much that goes into it, but basically 100 years ago, Einstein predicted that if you have two massive objects going around each other and they merge, you'll get a blast of radiation, and that radiation doesn't come in the form of light like we're used to seeing. It's actually ripples in the fabric of space and time. Space expands and contracts, and time expands and contracts, and these waves will flow outward. And basically the stronger the gravity that you have from an object, the bigger these ripples will be. And the biggest thing, the strongest gravity we have is from black holes. And if two black holes collide, they actually send out this blast of gravitational waves, which are literally ripples in the fabric of the universe. And it turns out they're super hard to detect. And for 100 years, nobody found them until 2015. And they announced this discovery that they'd found it from two black holes merging. Well, it turns out any objects going around each other will emit gravitational waves. The Earth going around the Sun emits gravitational waves, but they're very mushy and super hard to detect. The stronger the gravity from the objects that are doing this, the easier they are to detect. And it turns out neutron stars, which are extremely dense objects, they're basically the core of a star that's blown up. The outer layers of the star explode away. It's a supernova. The core collapses, and it can form either a neutron star or a black hole, depending on various circumstances. If you get two of these neutron stars orbiting each other, they will eventually collide, and you get this blast of gravitational radiation. Earlier this year, in October, they found this. They detected a pair of neutron stars that collided, sent out this blast of gravitational waves, and that was detected on Earth. The cool thing is that when black holes collide, they don't give off any light, as far as we know. They just collide, and you get gravitational waves. When neutron stars collide, they're different. They may collapse and form a bigger neutron star. They may collapse to form a black hole. But either way, there's a lot of matter that gets blasted away and gets very bright, like a supernova. And that was detected as well. So for the first time, we saw a gravitational wave event and an electromagnetic, a light event. And it was seen all across the electromagnetic spectrum. Radio waves, optical, high energy gamma rays, X-rays, just everything. This thing blew out a huge amount of radiation. And it turns out we thought or we thought beforehand, we think these kind of events create a lot of heavy elements like gold and platinum. And it turns out that when they investigated this event, the way the light was emitted made it pretty clear that that's what these things are doing, and that most of the gold that we know of in the universe is probably created in these sorts of neutron star collisions. And that was a long-standing mystery. Regular old stars blowing up can make gold, but not very much. And the amount we see on Earth doesn't make sense unless there's some other source. And it turns out it's these colliding neutron stars. So it was a big freaking deal. It doesn't answer all our questions. I can think of one or two more. What's dark energy? How the universe formed, that kind of thing. But it answered a lot, and so it was very exciting. And it also it opened up a new realm of astronomy where now we can study how these things work from their gravitational radiation and not necessarily just from the light they emit. So that's pretty awesome that we now have all these different tools to investigate the universe.
Wow.
So like I said, I can't tell you a little bit about it. I can tell you a lot.
So is there
And again, skimming the surface there.
is there a planet made out of
If
gold?
you want to know
out
more
there?
about these, you can go to my blog. You go to sci-fi.com/badastronomy, and I've been writing about these things. I'll have another one up on Monday. Actually, they found one back in June. They just released the results, and there's some interesting things about it that I think people will like, and I'll have that article up on Monday.
So now that we can detect it, these actually seem to be fairly commonly happening.
There are black holes merging all the time somewhere in the universe. Galaxies are big. They have 100 billion stars in them, and there's some percentage of those that are black holes and some percentage of those which are orbiting black holes. And there are, 1 trillion galaxies in the universe. So if these things happen in any given galaxy once every million years, I don't know, I'm just making that up. So every million years you get some black hole merger. Let's see. So every million years, there are 31 million seconds in a year. So that's 31 million. And 1 trillion is a million. So that means they would happen once every 30 years somewhere in the universe. We know they're happening more often. So I can just do this math in my head, and I'm sorry if I just, losing everybody, your eyes are glazing over. But the point is, you can just say, we're detecting one of these, 2, 3, 4 of these a year. Knowing how many we should be able to detect tells you how many of these things are happening in the entire universe, and how often we should expect them to happen in our galaxy. And the fact of the matter is, you can just write these numbers down on a piece of paper and figure that out. So these things are happening, fairly often somewhere in the universe.
And
it's pretty cool.
So we're actually getting all this. We're getting these gravitational waves from other galaxies.
Oh, these are happening very far away. The one I just wrote about was the closest black hole merger seen so far, and I think it was a billion light years. No, it was a billion light years away. I'm not sure, but it's something like that. The neutron star collision was only a few 100 million light years away.
Wow.
It's a long way. These black hole mergers can be detected from a long way off too. And we're going to be launching the European Space Agency and NASA are going to launch a space gravitational wave telescope that will be so sensitive, if it works, it will be able to detect every single black hole merger in the universe. So every time one of these things happens, it'll see it. Doesn't matter where it is or how far away or anything. So that's pretty amazing. I'm wondering how often. I mean, if that thing will be going off every 20 minutes. I don't know, but it's kind of
we
amazing.
gotta dial down the gain on this guy. It's too many.
Yeah.
Well, that's so cool. Now, we, as well as calling in and answering some awesome science questions, I believe we also had a lot for a giveaway for you to do.
Yeah, this is one of my favorite things. I love going through all the stuff I've gotten in the mail or picked up at conventions or whatever, and putting it together so that I can basically donate it to y'all and have people bid on it. So there should be pictures that you have. I put a picture on my Facebook page, and link to it on Twitter. So if anybody wants to, just go to twitter.com/badastronomer, and you'll see I just linked to it. And I got a picture of it. But I mean, I've got Star Trek minifigs. This is Captain Janeway in 7 of 9.
Oh.
I got a lot of Star Trek stuff this year. At a Star Trek convention, I picked up some. I don't know if you can see that. These are M&Ms. Star Trek M&Ms from the Smithsonian Channel. I have other Star Trek stuff someplace, don't I? You have an iPhone 6 or 6S, BB-8 phone cover.
Nice.
Oh yeah, Star Trek mini lunch boxes.
Oh,
Look at how cute these are.
so cute.
My daughter keeps one in her car and puts like gum and mints in it, so she has them.
For your food pills or
Yeah.
science things.
So I've got. I don't know why. This has been the year of the baseball cap. I have a SpaceX baseball cap. This is a Falcon 9 baseball cap from SpaceX. I'll just throw that on the floor. And this one's hard to see. It's a sci-fi one.
Right? Yeah.
Like, can you see the
Yeah.
Black on black. I
sci-fi
like it.
logo there? There we go. So that's pretty cool. And Sci-Fi, because I write for Sci-Fi now, they sent me some swag, and it came in this really cool gift box. So I'm going to put a lot of this stuff in the gift box and send it to whoever wins. Stickers, laptop stickers from Sci-Fi. Look at robot,
Nice.
zombie, Sci-Fi logo. And the two real coolest things, I think, they sent me an Amazon Echo Dot with a little Sci-Fi box.
Nice.
So this is an Amazon Echo Dot. It's a real thing. I don't want the government spying on me, so I'm giving it away. And that's a big one.
So
Worth like
whoever
$100.
gets it, they'll think is you.
Yeah, exactly. I can't. There's no joke I can think of fast enough for that. But yeah, so that's nice. And then, of course, as I do every year, I don't know if that's focused. Here we go. Right about there, maybe.
Yep.
Yeah.
This is a meteorite. It's an nickel iron meteorite. Fell in Russia in the 1940s.
Oh.
Weighs about 13 grams. So what is that? About 2/3 of an ounce, something like that. And I collect meteorites, and I've written up a description. And whoever wins this will win an actual rock from space. Although it's not rock, it's metal, and you can feel it. It's much denser than rock. And I love that. I love giving these away because it's a piece of space you can hold in your hand.
Yeah, that's awesome.
Super cool.
And there's other stuff here too. And a Pluto Christmas ornament made of paper. It's actually photo Pluto. I mean, with some information on it. Oh,
That's super cool.
SMBT Saturday Morning Breakfast Cereal DVD.
Nice.
That's for adults. If you read Saturday Morning Breakfast Cereal, that should not surprise you. And a handful of other things. So whoever gets this, I'm going to box this all up, personalize the meteorite description, and send it off Monday.
Awesome.
All right.
Super cool.
All right,
James,
so
how do we get this
yeah,
started? Get it started, James.
Is this on? Can you hear me? I believe I'm assuming that you guys can hear me. So we were gonna do a donation drive for this guy.
Yay.
Just to give as many people an opportunity to win this amazing lot from Phil. And as I mentioned to you, Phil, just before the start here, we generally try to do donation drives within like the $5 to $10 range. So again, as many people can enter as possible. And generally we try to add like an exact cent number, so like $5.58, so we can track that in our back end system a little bit easier.
Okay.
So if you have a dollar amount between $5 and $10 with maybe a number that is meaningful to you or to space or whatever it may be, we can start running that donation drive for a little bit.
Okay. Well, numbers have no meaning, so
Meaningless. All right. Perfect.
and is this base 10? I guess because it's money, so I guess it is base 10.
It is, yeah.
You know, I was gonna go with pi 3.14, but since you want it between 5 and 10, how about we do 2 pi?
Oh.
6.28.
All right.
Excellent.
And 3.1415, so 6.2830. Yeah, so that we'll round it to 6.28, and that's nice because there are 2 pi radians in a circle. That's a natural unit, and I will be happy to lecture about that at the drop of a hat as well. But I will just leave it at that. You know, they're 360 degrees in a circle, but there's another unit called a radian. It's based on the radius. So there are 2 pi of those around the circumference of the circle, and that's 6.28. So let's go with $6.28.
Awesome.
Excellent.
Okay, so
Good.
we're going to say then for the next 45 minutes, if you get a donation of $6.28 in or multiples thereof, it will get you multiple entries. You have a
If you
chance to
bid
win this.
$6,280.
Yeah,
you're in.
you can have a chance to win this fantastic lot from Phil, and we really appreciate you calling in and chatting with us today. That was really awesome.
Of course.
Thank
And
you, as always.
thank you so much.
Well, I love what you guys are doing. I mean, I don't love that you're playing this game because, my God, that's just torturous.
Yes, it is.
Who's actually got the controller? I can't see.
It's
You go.
it's Kate, Big Kate. I'm
Over there on the
dressed
other
as
side.
a princess.
Oh, there you are. Okay.
See me?
Yeah, I live in the middle of nowhere, and my internet connection isn't not the best, so everybody's really fuzzy. That's why I'm not sure who's sitting there. I can't write. Oh, there we go. Oh, hello. How are you?
There you go.
Your Majesty.
There you go. That's right.
Yeah, so I mean, I know about this game. I've never actually played it, but I know about the history
You
of it with
should.
Penn
You
and
should
Teller and
play
all
it,
of that.
Phil. You should.
And I know how
hours.
torture it is. They're just the evil geniuses, those guys. So the fact that you put yourselves through this, and then let people like me come on and blather on and on to raise money for kids who are sick is amazing. So thank you for doing this and spending so much of your time to make other people's lives better. That's just the best.
Thank you so much.
Oh,
Hey,
thank
now
you
wait
so
a minute.
much.
Whoa. My connection just got better. You said your name, Emily?
Yes.
Is that a Mobius strip?
May I have the words, Mike?
Oh, Emily's our knitter.
No, this is not a Mobius strip, though I have knit
Oh.
those before. This is a giant Wonder Woman logo.
Oh wow! Oh okay. The way you were holding it, the way it was sort of draped down. It had a single twist in it that I could see, and I was like, oh wow, that'd be awesome. So I'd bid on a Mobius strip scarf.
Next year.
Maybe next year.
Of course, the bidding. Anyone? Would be one-sided. No, really? Not even a smile? All right. Fine. Okay, now what?
Now
Yeah,
you're
well,
good.
we've got it started.
We've got it
so
started.
now people are donating $6.28 right now as we speak.
Is that going in the chat room?
It's going in the chat. We're watching our numbers
The
going up.
yeah, the donation total is climbing up.
It's
We've
climbing quickly.
raised about $1,000 in the last couple minutes here, so
Oh wow!
it's doing very well. So
Cool.
Everybody wants
I'm
a
trying
piece of
to-
space.
If it
Let's
goes
see.
into-
Donate. Submit. Is that under
Special
donate?
order
Where is that?
The open
Schedule prizes.
if you go to if you just look at the main website there,
You can see the
desertbus.org,
numbers
you're going to see the
coming up.
number just jump and jump and jump. And that's everybody donating, trying to get in on
right
this.
there. Like
That was a
another
huge jump.
From,
We-
$150, $200 right there.
Yeah, we've got
I'm
up to
watching the number go
$2,000.
down.
You lie.
Yep.
You
Amount
lie.
to next hour, and it says.
Oh no, top left.
Oh, yeah.
Top
Yeah,
left.
top
the blue,
left.
in the blue.
Should say
Oh, there it is.
97,000.
Oh,
Yeah.
97061.
See that number?
Okay.
And
Oh,
it should just
oops,
keep
see,
jumping
just
up.
changed.
97105. Wow, look at that.
Yeah.
Yeah.
Thank you.
So we
That's
will
all right,
Click on
Chef.
join the
I'm
chat
very
room.
grateful.
I should have done this before. 'Cause it's always fun, live watching somebody fooling
Oh,
around
there's
with their,
another big $200 hit.
where they're
Oh,
clicking.
This is
Oh.
definitely going up. This is
Going up super fast
very
now.
likely going to push us past 100,000, which is
Which
Oh, that would be awesome.
incredible.
Yeah.
So this is going to run for another 42 minutes. So you got lots of time to get your donations in.
Okay, I'll make sure I tweet it again once we're done here.
Absolutely.
Oh, that'd be
That'd be
great.
fantastic.
Yeah, all the porn bots who follow me, I'm sure will jump right in. People are always like, wow, you have so many followers. And it's like, really, there's like 4 people in like Wisconsin who follow me, and everybody else, I think, are Russian bots.
That's awesome.
So let's see. Somebody's saying pi or tau. Yeah, that's funny. Of course, pi is 3.14, and people have said tau is twice that, 6.28, which is a more natural unit. There's actually people who get really fiercely upset about this. It's kind of like, Kirk versus Picard or VI versus Emacs if you're a Unix person. I don't care.
Oh.
Pi is fine. If you introduce 2 pi, you wind up complicating certain some things get simpler and some things get harder. So I don't think there's any real reason to do that. But it's funny to see people talking about that here.
You started it,
I'll
actually,
bet.
there, Phil.
Yeah, the opening up the can of
Pie.
these.
Oh, look at this. Here are all the and I should say all the people voting for VI are correct. They're the right ones.
We just got a big thumbs up from our engineering department.
Actually, yeah, VI is the way to go. Emacs is how Ferengi make love, right? They use Emacs on
That's
there.
it. Umox, isn't it?
That's a super. Okay. Oh, you got it. Okay. Star Trek inside dorky joke. And what's funny is, I mean, I'm a Unix guy through and through from grad school, and one of the reasons I bought a Mac after having a PC for so many years is because they started using Unix, and I recently wound up having to do some consulting work, which I can't talk too much about yet. Be announcing it pretty soon, but I'm doing some consulting work for somebody, and I had to install Fortran emulator on my Mac, the one I'm staring at right now, and I had to install Fortran and then get the software to work, and I started running it, and it was like all the fun of the work I did in grad school without any of the pain, and it's kind of funny to think that this computer I bought recently is like 100 times more powerful, probably 1,000 than what I did my PhD on 20 years ago.
So I have a question for you.
So there you go. Sure.
All right. So we've done Pi and Tau and Emacs VI and Umox and Quark and the Ferengi, which actually brings me back to Quark. So VHS versus Betamax, because that's definitely what I watched that on.
Who cares? You know?
I still have a Betamax player.
Neanderthals, do you prefer the Oak Club or the Beech Tree Club? Who cares? 100,000 years ago. Yeah, I don't actually know that much about it. I know Beta was supposed to be better, better density, better quality, and I know that. When I was last year, I was a science writer for Bill Nye Saves the World, his show on Netflix.
Right.
And when we moved into the office and I went in to talk to the showrunner, along the wall were closets, and and it was supplies and stuff. And somebody opened it while I was standing there talking to him, and with the pens and everything, there was just a rack of shelves of beta tapes, and I was like. Really? What are we going to read these with anymore? I haven't seen a beta tape in forever. And I know that the Mystery Science Theater 3000 revival, one of the perks for donating to them was a VHS tape, because my daughter got one in the mail.
Oh, right.
It was hysterical. What are you going to do with this? But of course they did it on purpose, because that was their show, was keep circulating the tapes was their rallying cry. I don't know, VHS is an acronym, and Beta is a Greek letter, and I like Greek letters, so I'll go with Beta. For totally random.
So Phil,
After all of that prologue.
You've pushed us, Phil. We're almost at
Beta.
99,000.
Right.
It's excellent.
Yeah.
Yeah. Thank you so much, and thanks for your donations towards the kids. It's awesome.
Yeah, thanks.
My pleasure.
So I think
Ooh,
we'll
98.
we'll let you go and have that continue on for the next 36 minutes, and we'll get some continue with the donations. Oh wait, let's just. We're so close to 99.
Oh, here comes 99.
Yeah, I'm watching this go on.
Yeah, it's beautiful.
Less than $50.
Yeah.
What's funny is what I'm seeing on the website is actually lagging behind by 10 seconds or so, our talk.
Yeah.
So
Yeah.
I'm
We know
going to
what
hear you
happens.
screaming, but then I'm going to see you just kind of sitting there. That's weird.
Yeah.
That's
Come
a
on.
40.
Oh, we're
Here
so
comes,
close.
here comes. Someone touch it. Someone touch it.
Poke it.
Give it a poke.
Poke it.
Poke it.
Poke it.
Poking.
Go on.
Come on.
Poke it.
There we are. Poke it.
Yeah, I'm seeing it
$6.
98,964.
Yes.
Oh, so close!
98,
Can we-
98.
So we're at 99,000?
Yeah.
Yay.
Yeah. That's awesome.
There it is. Okay. Yay. Well, I'm seeing all that confetti falling. When I look at you guys now, it seems all cleaned up. That's very fast.
Yeah.
Pretty
Very
efficient.
efficient.
Doing good work.
All right. Well, thank you so much, Phil, and we will be continuing to gain from that Bad Astronomer lot. And thanks for calling in and answering some awesome science questions.
Well, thank you. It's a pleasure every year. I'll have to figure out something to top this for next year. But and again, good on y'all for doing this. You're doing good work, and it's just wonderful. And in times like this, we need a little bit of good works to go a long way. So thank you.
Indeed.
Thank you for
All right.
supporting us.
Thanks, Phil.
Thanks,
All
guys.
Right.
Bye. All right, everybody, and now we're